This is the report for the first lab in Physics 2212. So the introduction, we're going to start with the fundamental principles, using electric and gravitational forces to observe how charged objects interact with one another in space, and we'll begin by making charge tapes and determining their charge based on their interactions with objects of known charge. And then we will use these tapes to study the balance between gravitational and electric forces, and estimate the charge, amount of electrons, and other things on a charge tape. So for the experiment, we'll start by creating a charge tape. Then we will observe its interactions when other objects of known charge are brought near it and determine its charge. Then we'll create an additional tape. Then we'll hang one tape above the other and measure the distance between them when the top tape starts to float. Then we will record the length of one of the pieces of tape. We'll convert measurements as needed and then compute the desired calculations. And here's an image of how we'll have our experimental setup. There's going to be a tape on the top that you'll just hold even over some books and then bring another charge tape underneath it. So for the data and observations when I did this experiment, I found that the U-tape was repelled by negatively charged objects. This means that the U-tape has a negative charge. The top tape started floating when the two tapes were 0.7 centimeters apart, and the tape was 24.2 centimeters long. And since we know that clear tape is around 1 gram per meter, we find that the tape weighs about 0.242 grams. So next is our calculations. Here's our force diagram to start. This is the same picture from before of our experimental setup, but I've added the forces and the environment. They're mostly vertical forces. It's likely that the electric force will have a couple of other different directions in it, but since we're assuming that they're point charges for our calculations, we're just going to say that it's a mainly vertical force and that the force of gravity is the other mainly vertical force, and that those will be approximately equal in magnitude but in opposite directions. So here's our calculations. On the top left, we find that the force of gravity on tape B can be found by negative mg. M is the mass that we found is 0.242 grams, and g is the gravitational acceleration, which is 9.8 meters per second squared. And we multiply those together and find that the gravitational force is negative 2.3716 newtons. And then on the right, we have set this equal to the electric force and plugged in the formula for the electric force of a point charge. And since both tapes are assumed to have equal charge, we just have QB squared instead of QA times QB. And that just simplifies our math a little bit and finds just the one charge. And then we have algebra, and then we just plug in our values, including the constants and the distance between the two when they started to float. We find that the charge on the top tape is negative 1.5749 times 10 to the negative 7th coulombs. Then to find the number of electrons, we divide our charge by the charge of one electron and find that we get 9.843 times 10 to the 11 electrons in this tape. And then to find the number of atoms in this tape, we divide the tape length, that's 0.242 meters, divided by the size of an atom. And we find that there's 2.42 times 10 to the 9th atoms. And then to find the electrons to atoms ratio, we just divide the number of electrons by the number of atoms and find that for every atom, there's approximately 406.74 electrons. Next is the coding section. So the objectives for this are to write a program to produce a computational model of two charge tapes exerting an electric force on each other and experiencing a gravitational force. And then we will use this model to estimate the amount of charge necessary to float one tape above the other. So here's our code. We have some constants up at the top, and the objects, since we're treating the tapes as point charges, I just put them in as spheres, and they're 10 units apart in the y direction. We have our initial values where we find r as the distance between the two and the magnitude of r, and then we use those in our calculations where we find the gravitational force and the charge on one of the tapes the same way we did before. And this is the output of the program. The green ball is the tape B on top of the blue ball, which is tape A, and then it prints out the necessary charge to float one tape above the other. So for the conclusion, these are the assumptions that we had to make throughout the experiment. So we started by assuming that the magnitudes of the gravitational force and electric force on the top tape were treated as exactly equal. They probably weren't exactly equal, but for the sake of this experiment with the approximations, we could assume that they were. The long tapes were also treated as point charges with all charge concentrated in the center. And since the two tapes are made in the same way under the same conditions, they were assumed to have equal charge evenly distributed along the strip of tape. We ignored external conditions such as humidity, wind blowing, air resistance, etc. that could have possibly impacted the results, as their impact was likely small. And these assumptions are all reasonable because we were looking for approximate values to understand interactions, not precise values. So for the end of the questions, what if electrons had positive charge and protons had negative charge? The interactions would not change. Like charges will still repel and opposite charges will still attract. That's not going to make a difference, but it would reverse the calculations in this experiment. We'd be looking for excess protons instead of excess electrons, but our numbers would be about the same. And why is it important to handle the charged tapes as little as possible? This is because the adhesive side of the tape could be a conductor, which will impact its charge, and we go into that in a little bit more detail in the next question. What happens when the charged tapes come in contact with your hands or other objects? So the tape will transfer charges with whatever it touches. It could lose electrons and or protons to other objects or collect other charged particles. and every time the tape touches another object, its charge will change. This changes how it interacts with the desired objects and will therefore change the results of this experiment. This concludes Lab 1 video report.